Assalamu alaikum. In this video, the solution guideline for problem 6-12 in figure P6-5 and part C will be shown. So let us take the snapshot of this part and just paste it here. So as mentioned here, that assume rolling contact, so that means the link 2 and link number 4, these two rolling wheels are in pure rolling, means there is no slipping at this surface between link 2 and the ground and link number 4 and this ground or horizontal surface. So as we can observe, there are 4 links as shown by these digits. So this is link number 1, ground, which is actually not mentioned. So this is link number 2, and we can say that this link number 2 is actually the input, and similarly link number 3 is actually in the complex motion, because it's both points A and B where it has been connected with links 2 and 4 are moving revolutes. So this link number 4 is also in rolling contact, means rolling without slipping. So as there are 4 links, so according to the formula for the instance centers number determination, count of instance center means the formula is n into n minus 1 divided by r factorial. So r is 2 and number of links are 4. So in a similar manner, as we calculate for a simple 4-bar mechanism, there will be total 6 number of instance centers. So first of all, we should be locating the permanent instance center, and they are quite clear here that every pin, means pin A and pin B, are two permanent instance centers. But remember that this point C is actually, there is no pin, this is just an extended link means this is an extended point. Here is no connection or no pin, no joint is here. So and as we can observe that link 2 is in pure rolling, so that means this point, contact point, will also be an instant center, and this link number 4 is also in pure rolling contact with this horizontal grounded surface. So this contact point will also be an other instant center. So I can just, for example, first of all show the permanent instant center here. For example, I can write it here. For example, just this instant center is between link number 2, 3 and here this instant center will be between link 3, 4 and here this instance center will be between link 1, 2, and here this will be instance center between 1, 4. Here now I can input the I notation for the indication of instance centers. This here, another one here, for example. So as we have observed that 4 instance centers have been found out, of which instance center 2, 3 and 3, 4 are actually we can say permanent instance center, because as the same pin will be at each and every instant. But instance center I1, 2 and I1, 4 are, though they are quite obvious and they can very easily be determined from the diagram, but these two instance center will be changing at each and every instant, because when the wheels will be rolling, so this contact point will be changing at each and every instant. So instance center will be changing at each and every instant. So these are actually and remember, as the ground is stationary or static and its velocity is 0, so that means the velocities of instance center I1, 2 and I1, 4 will be 0. Linear velocity will be 0. So we can also say that this link 2 and link 4 are actually in pure rotation about these instance centers in their respective instance center at the moment when they are in contact with this ground link 1. So as we can observe that 4 instance center have been found, and there are actually remaining 2 further instance centers which are unknown. So we can, for example, draw a linear graph for determination of those instance center. So similarly we can just divide this circle into 4 number of parts, like we did already here randomly. So just mention here the link numbers. This is link number 2, this is link number 3, and this is link number 4. So now simply connect these permanent instance centers. like this. And after that, now we are actually required to find the instant center between the links which are not directly or physically connected with each other. For example, link number 3 and link number 1 ground, because these two links are not directly connected. And in a similar manner, this link number 2 and this link number 4, which are not physically or obviously directly connected with each other, they have no direct connection with each other, there is no common pin between these two links as well. So in order to determine instant center between common instant center for the link number 3 and link number 1 ground, so we will be drawing this diagonal. So just make it in somewhat dashed pattern here like this. So instant center I1 comma 3 will have to be found out using trio 1 2 3 and 3 4 1 or 1 4 3. So as we can observe, instant center I1 comma 2 is this, and 2 comma 3 is this instant center. So we can actually locate here, this is instant center I1 comma 2 and this is instant center I1 comma 4. So here as we can observe that instant center 1 comma 3 will be located on a line connecting instant center I1 comma 2 and I2 comma 3. So that means I can just draw here a straight line connecting these two instant center and just change its thickness of this line here like this. So so the third instant I1 comma 3 will be located on this line. So at this moment, as we can observe that this link which in link in complex motion is exactly horizontal. This line AB is exactly horizontal and ground is also exactly in the horizontal location. So the second instant center using second trio, we can observe that this is instant center I1 comma 4 and this is instant center I3 comma 4. So in a similar manner, a second line can be created connecting these two instant centers like this. As we can observe here at this moment that at this moment that these two lines are actually parallel, because the reason is that at this instant this line AB is horizontal and this line is also horizontal, means ground surface is also horizontal at this moment. So that means this is actually a parallelogram shape here. I1 comma 2 and I2 comma 3 and I3 comma 4 and I1 comma 4, this is actually a parallelogram. So that means these two lines are parallel. So that means instant center I1 comma 3 will be either on this line or in this line, and when these two lines will be extended up to infinity. So at infinity I1 comma 3 will be located on these two lines, because these two lines will actually be meeting at infinity. I1 comma 3 will be located on the extended line connecting I1 comma 2 and I2 comma 3. So I can just write it here. For example, uh, in a similar manner, we can just write it here that I1 comma 3 uh, here again I can just copy or just type it here, that will also be equal to 1 comma 3. Similarly here I1 comma 3 1 comma 3. So so actually means that instant center I1 comma 3 will be located at infinity at either of these two parallel lines. So these instant center I1 comma 3 will be located at infinity. So we can mention here infinity, or I can just write it here. This is infinity symbol, simply like this. So in this way instant I1 comma 3 has been located. After that we will be determining the next instant center like this. For example, change its color and make it dotted, because these links are not physically connected. So between instant center I2 comma 4 will be located using trio 1 2 4 or 1 4 2 and 2 3 4 etc. So using the upper trio, for example, instant center I1 comma 2 and instant center I1 comma 4 means the instant center will be that will actually be connecting third instant center will be on this line. Instant center I2 comma 4 will be located on the line connecting instant I1 comma 2 and I1 comma 4. So these two instant center contact point. So the third instant center will be located on this line, and in a similar manner using other trio, as we can observe that the instant center I2 comma 4 will be located on the extended line connecting the two instance center 2 comma 3 and 3 comma 4. So that means we can here proceed a line in a similar manner as previously. So on this line, as we can observe in the both direction, actually this line should be drawn in the both direction, because here like this, for example, sorry, just here like this. So that means instant center, just crop these further portions. So the instant center 2 comma 4, that we can just copy this notation, that will be located at infinity. I will just be modifying that. Here we can just write, for example, I 2 comma 4 here like this. So we can just copy and paste here like this. We can copy and paste it here. Here like this. So in this way permanent instant center I2 comma 4 will also be located at the infinity. Actually there is only one permanent instant center, but as this is located at infinity, we are not sure that maybe either on this side or on this side at one instant. So in this way all 6 instant centers have been found out. These 4 instant center I1 comma 2, I2 comma 3, I3 comma 4, I1 comma 4 and I1 comma 3 and I2 comma 4, all 6 instant have been found. So next I can also relate another problem using some known data here, as in problem number 6-16 to 20. We can see here that in the problem in 6-17, the author has written the statement that the linkage in figure P6-5C I1 comma 2A is 0.75 and AB is 1.5 and AC is 1.2 inches. So these dimensions are in inches. The effective crank angle in the position shown is 77 degrees. So that means I can input here, say that this is the crank at this moment. For example, we can say, because this point is actually I1 comma 2 is like the 0.02 because this is like a crank grounded pivot, so this point has 0 velocity. So we can assume that this point is O2 and up to here, as we can observe here, that I12A means here I can show here just that this I1 comma 2 up to A, this is actually the effective crank. This is the effective crank. So its angle with the horizontal is, for example, I can just mention here, sorry, I can mention like this, that this. So the angle that has been mentioned here, that is actually 72 degrees, for example. So this angle is 72 degrees, and angle BAC is 30 degrees. So means this angle, as I can mention here, that this angle is actually 30 degrees. So just type it here, 30 degree, that this angle BAC means the angle is at point A. So BAC angle at A is 30 degree, because while we write like this, so that means the vertex of the angle is at the middle point, means at point A. So this is 30 degree angle. So we will also be calculating the velocity or for point C as well in this problem. So what are the requirements here? That find omega 3, omega 4, VA and VB and VC for the position shown. For omega 2 is equal to 15 radian per second. So omega 2 is given in the direction. So here part A, I will not be guiding this part, so student can solve it themselves. So our interest is actually this second part using instant center graphical method. So in the graphical method, we can simply draw this diagram according to scale, and then the values will be converted. So here I will be simply explaining according to data. So as we can observe, our requirement is that first of all find omega 3, means the angular velocity of this link which is in complex motion. So to find or determine the velocity of this link ABC which is in complex motion, so that velocity can be find first of all finding the velocity of the instant center I2, 3, means of this pin or point A, because this is the effective crank. So as we can observe, the angular orientation of the angular velocity omega 2 is counterclockwise. So that means the velocity will be we can say perpendicular to this link in this orientation. Just make it perpendicular somewhat, so like this. This will be actually the velocity V A R. This is the velocity of point A or velocity of I2, 3, because point A or I2, 3 at this instant is actually common between link 3 and link number 2, but at this moment we are considering it are to be located at link number 2. So at the moment we can observe that the magnitude of VA that can be calculated here, I can write it here, that VA is equal to actually VI two comma 3. So like this. So as we can observe, this velocity VA is actually perpendicular to this link. So the magnitude of the velocity will be equal to, as we can observe, that this I12A is 0.75. So we can just type it here that this is equal to 0.75 and multiply it by, just change its font size, for example here. So 0.75 multiplied by this angular velocity omega 2, and omega 2 here it is shown, it is given that it is 15 radian per second, so multiplied by 15 radian. So this comes out to be, that can be calculated here using calculator, that we will be simply multiplying 0.75 multiplied by 15. So this comes out to be 11.25. So 11.25 inches per second, inches per second. Like this. So as we can observe that the velocity of instant center I2, 3 or VA has been found out. So now that instant center or point A will be shifted to link ABC. So when it has come to has been shifted on link ABC, we can observe that the instant center for this link number 3 is actually, instant center is at infinity. So the velocity of this link number 3, as we can observe that the instant center I1, 3 is actually located at infinity. So that means by definition we observe that if we write the formula for the angular velocity for the link number 3, so omega 3 by definition will be equal to this velocity VA or VI 2, 3. This velocity will be divided by the instant center, means A up to I1, 3. So as we can observe, this instant center I1, 3 is located at infinity. So that means the distance between this point A and the instant center I1, 3 will be infinity. So that means we can just write it here, that that if we can write that VA divided by infinity. So that means something divided by infinity, this comes out to be 0. So that means the angular velocity of link number 3 at this very instant or this moment is actually 0. So that means that link number 3 is not rotating at this instant. Maybe in the next instant it may be rotating with some angular velocity, but at this very instant, because this link is exactly horizontal and its instant center is located at infinity, so this is not rotating. So that means this link at this moment is in pure translation. So when a body is pure translation, so the linear velocity of each and every instant in that body is same in magnitude and direction. So that means at this instant the linear velocities of point A, B and even point C are quite same, because this link number 3 is not at this moment in complex motion, but it is in a pure translation. So like this. So that means the velocity of angular velocity for this link number 3 is actually 0. So that also means that velocity, for example velocity VB, means this point B, which at this instant is at link number 3, its velocity will be same as that of velocity of point A. So that means this linear velocity will also be equal to 11.25 inches. So in this way, and its direction of velocity will be same, because the direction will also be same and parallel to this velocity VA. So I am just roughly drawing here that this will be equal to actually the velocity V at this moment. And in a similar manner, velocity of point C will also be parallel to, so this will be equal to velocity of point C, same in magnitude and direction. And if we consider the angle, so here the angle mentioned is 77 degree for the crank. So I have mistakenly typed it here 72, and this is actually 77, so I can just correct it here, that this is equal to this is actually equal to 77 degrees. Here like this. So this was angle was equal to 77 degrees. So that means that the angle for the velocity of VA is actually I can just show here once again, just draw it precisely here. So actually I can just roughly draw here, sorry, that here like this angle will be equal to, actually this angle is 90 degrees, so 90 plus 77, so we can say the angle of this velocity VA with the horizontal is equal to as we can write here. For example, I can type here that theta A, for example, theta of velocity VA, that will be equal to 77 plus 90 degrees, so this comes out to be 167 degrees with this horizontal. So that means the every velocity will have the same angle. So if here I can, for example, just draw this horizontal line, so this angle will also be same and this angle will also be same. So that means all angles have been found out, so because this link is in pure translation. So now we can shift this point B at this link number 4. So as we can observe that these are identical wheels, link number 2 and link number 4. So here the length of the effective rocker link means distance between I1 comma 4 and I3 comma 4 or point B is same as in the effective crank. So when this velocity VB will be divided upon the same radius of 0.75, so the velocity of the angular velocity for this wheel, this link number 4 will also be same. So that means its angular velocity, I can just write it here that omega 4 will be practically equal to actually omega 2. So omega 2 is actually 15 radian per second. So this velocity will also be same. So in this way all velocities have been found out in this way. So this problem has been solved. If you have any question, you can fairly ask. So now I will be guiding the solution for this part D of figure P6-5 and problem number 6-12. So let us copy the snapshot of this part D into Windows Paint. Here, for example, I can just here like this. So now as we can observe here again, here are 4 links. Link number 1 ground, link number 2 is actually the input or crank link number 3 which is actually this roller follower. This link is actually in complex motion because it both contact points are in moving links, means this contact point and this pin both are moving. So if the connection point of a link are both moving, so that link will be in complex motion. And this link number 4, which is actually like the oscillating rocker link, which is actually in this problem is in pure translation. So this is link number 4. So according to the formula to count the instant centers, so the result is actually equal to 6 number of total instant center. So we will first of all be listing or determining the permanent instant center. So every pin is actually a permanent instant center. So just for example mention here in a similar manner. For example, I can type here. So this will be instant center I1 comma 2. So I1 comma 2. So this pin will be permanent center I1 comma 2, and this pin will be instant center because this pin is actually connecting this link number 3 and this link number 4. So we can say that this pin will be instant center 3 comma 4, like this. So and again, as it has been mentioned here, that here is the rolling contact, so that means the connection between this cam link number 2 and link number 3 follower at this instant is pure rolling. So that means this point will be having the same velocity. This point, contact point, will be having the same velocity. So this will also be the instant center. So I can just mark it here with a simple dot here, like this, that this contact point will also be the instant center, and this instant center will actually be changing at each and every instant. So this instant center will be between link 2 and 3, 2 comma 3, just mention it here. And as we can observe that this link number 4 is in pure translation, and this is acting like a rocker of infinite radius, so that means that instant center I1 comma 4 will be located at infinity. So just draw a, for example, line at infinity from this point here. So just mention here that this is instant center I1 comma 4, sorry, instant center I1 comma 4 is actually at infinity. So now for example, just type the I symbol. So just paste it here. This is instant I1 comma 2, and this is instant center I 2 comma 3, and this is instant center I 3 comma 4, and this is instant center I 1 comma 4. So in this way 4 permanent instant centers have been found out. I1 comma 2, I2 comma 3, I3 comma 4, and I1 comma 4. And remember that this I1 comma 4 is actually at infinity. So now the problem remains to find the remaining 2 unknown instant center, because there are total 6 number of instant centers. So we can draw a linear graph for this. So and just divide it into 4 segments, just like this. For example, this is 1 2 3 4, just mention it here. This is link number 1, this is link number 2, this is link number 3rd, and this is link number 4, like this. So just connect these lines here like this, like this. So after that we are actually finding the instant center between any two links which are not physically connected or directly connected with each other through any pin. So as we can observe that we will be determining the instant center between link number 2 and link number 4, link number 2 and link number 4, because these have not been directly connected between them. This link number 3rd or follower is there, and also ground is there. So that means instant center 2 comma 4 is still to be determined. So we will be just connecting this diagonal of this quadrilateral. So using upper trio 1 2 and 1 4 instant center, as we can observe that this is instant center I1 comma 2, and this is instant center I1 comma 4 here. So as we can observe that instant center I1 comma 4 is actually located at infinity. So we will be drawing a parallel line with this effective rocker link. This is effective rocker link number 4, this is effective rocker link. So we will be drawing a line parallel from this point of link number 2, and we will be proceeding this line in both orientations. Just make it like this, extend it in both direction parallel to this effective rocker link. So this is at infinity. Instant center I1 comma 4 will be located on the line of instant center I1 comma 2. So I1 comma 2 is here, I1 comma 4 will be located at here at infinity. So using other trio, instant center I2 comma 3 is this point, and instant center 3 comma 4 is this point. So just draw a line connecting these 2 points like this here exactly. So as we can observe here that here intersection is taking place, so that means this is actually the instant center. I can write it here. This is instant center I2, 4. I2, 4. Here like this. So this is the instant center I2, 4. So in this way fifth instant center has been found out. After that there is one instant center that has been left, so that can also be found out. So we can draw the other trio in some different color, other diagonal here like this. That instant center will be actually between link number uh, third and link number 1, because these are not actually directly connected, because between them is link number 4 and link number 2. So here this other diagonal has been drawn. So using the trio 1 2 3 and 1 4 3, so we can determine that instant center I1, 2 is here, here this is instant center I1, 2, and instant center 2, 3 is here at this moment. So we can draw a line in, for example, a different color here, that this will be the actually the contact point here like this. So proceed this line in both orientations here like this. So instant center I1, 2 and 2, 3 on this line. Third instant center I1, 3 will be located on this line using Kennedy theorem. So after that use this other trio 1 4 3, that this is instant center I1, 4 is actually at infinity, and this instant center I3, 4, as we can observe here, that this pin is actually the instant center I3, 4. So as we can observe that this instant center is actually at infinity. So at infinity this instant center I3, 4 will be on the same line at which this effective rocker is there. So we can in a similar manner draw a parallel line as we had drawn this line for this trio for to find the instant center I2, 4. So simply draw the line here like this at this moment. So as we can observe that here intersection is taking place. If I can make it a bit zoom, so this will be actually equal to instant center I 2, 4. So we can just mention here that this will be instant center between this instant center will be I1 comma 3. Just mention it here. So this here like this. So in this way, permanent unknown instant center have been completed. All 6 instant centers have been found out. So here we can use some assume data for some calculation. For example, if we want to determine the angular velocity or angular rate of rotation for this follower link, so we can calculate. So again, for example, we can assume some random data. For example, I can mention here that, for example, we can assume that omega 2 means the velocity, here omega 2 is, for example, I can simply mention here 5 radian per second. So the angular velocity for this cam is actually 5 radian per second, assume. And for example, as we are familiar that cam is actually has a varying radius at each and every instant. Cam profile is generated with the varying radius. So at this moment, for example, I can just say that the effective radius at this moment is, for example, I can mention it here that, for example, I can say that O2 I2 comma 3, this contact point is actually instant center I2 comma 3, like this. So just assume that, for example, this distance is, I can say, for example, 3 centimeter. I can say the radius for the cam at the moment considered. This distance here, this is actually 3 centimeter. So that means the velocity of the cam means the velocity of instant center v of I 2 comma 3 will be equal to the product of this r omega. So r is O2 I2 comma 3 and omega 2 is equal to 5 radian. So I can just simply multiply that 5 multiplied by 3. So that means the velocity will be equal to 15 centimeter per second. 15 centimeter per second. So what will be the direction of this velocity at this moment? Because the angular rotation is in the counterclockwise orientation, so that means the velocity at this instant of this point will be exactly in the vertical orientation, because this line is actually almost horizontal, so that means the velocity will be perpendicular. So this is actually the velocity of I instant center 2, 3, like this. So that means the velocity of this point has been found out, this common point. So now that point will be shifted on to this link in complex motion, which is link number 3rd. So we will be we will be finding the radius for this link number 3rd. So as we can observe that the instant center for this link number 3rd is actually this is instant center I 1, 3. So we will be finding the distance of this velocity up to this point here. The velocity is here, and we will be finding the distance between I2, 3 and I1, 3, this side. So we can, for example, first use some angles. For example, as we can observe that we know the distance between instant center I1, 2 and I2, 3 or O2 I2, 3. So here, for example, if we know the radius of this follower, for example, I can assume the follower radius. For example, I can just mention here that R3, this is the follower radius. Sorry, here type it here. So follower radius is assume for example, I can say it is 0. For example 0.8 centimeter. This is the follower radius at this moment. So the radius for this follower is assumed to be 0.8 centimeter. So at this moment we consider another fact that as this the center of this follower is actually offset from this crank grounded pivot. So usually this offset can be directly measured, or it must be practically known when physically fabricating. This offset means the distance between this horizontal line or crank grounded pivot line and this follower center line, because this is actually the center of this pin is actually the follower offset line. So this offset is also usually known. So that offset I can just for example type it here, that for example I can say the follower offset. I can furthermore mention here that follower offset is for example that can just be assumed that it is 0.4 for example 0.4 centimeter for example, just a random data. So follower offset is here. So that means that this third side means the distance between this contact point I2, 3, or this is also labeled use as point A contact point. So this distance I can type it here, that distance between A I 1, 3 AI 1, 3 will be equal to actually 0.8 square minus 0.4 square and square root of this. So this comes out to be, as can be calculated here, that 0.8 square minus 0.4 square. So this comes out to be here 0.6928. So just for example I can copy paste here. So that means approximately 0.7 at this moment. I can say 0.7 centimeter will be AI1, 3. So that means this velocity VA or VI2, 3 I can also mention here that this velocity VI2, 3 is actually equal to the velocity of point A, because this contact point is also labeled as point A in the diagram. So now as this point A is actually common and it is now on the follower, so this velocity is actually in pure rotation about this I1, 3. So that means I can mention here that omega 3 will be equal to velocity of VA or VI2, 3 divided by AI1, 1 comma 3 like this. So this comes out to be as the velocity of vi2 comma 3 is equal to 15 centimeter, because this was actually the velocity of point A. So 15 that will be divided by I1 comma 3. So this is I can just type here, this is equal to 0.7 approximately here. So this comes out to be equal to, I can calculate here that 15 and we can divide it by 0.7. So this comes out to be 21.42 radians. So up to 2 decimal we can observe that this will be equal to 0.2 radians per second. So omega 3 has been calculated. So as we can also observe that this pin B or instant center I 3 comma 4 is also in pure rotation about this pin. So we can find the linear velocity of the center point of this follower. So that means here we can write that the velocity of point B, I can mention it here, that for example here the velocity of instant center I3 comma 4 or this point B will be equal to B I 1 comma 3 bi 1 comma 3 multiplied by omega 3 like this. So that means bi 1 comma 3 is actually equal to the offset, this offset, because this distance is actually equal to the offset, because this line is the crank pivot horizontal line. So that means bi 1 comma 3 is actually 0.4 multiplied by omega 3, and that is equal to, I can just paste it here, that is equal to 21.42 radians. So here this comes out to be equal to multiplied by 0.4, so this comes out to be 8.57 centimeter per second. So just type it here that this comes out to be 8.5 centimeter per second like this. So in this way the velocity of point B has also been found out. So remember, in a similar manner data can be modified in the final term exam. So do this problem very carefully, and if you have any question you can fairly ask. So Here all the linear velocities and angular velocities have been found out as required. Angular velocity of link number third has also been found, and this velocity of pin B has also been found out, and same is actually the velocity of link number 4. So I can simply mention it here that now point B, which was actually at the follower, is actually a common pin between this link number 4 and link number third. So now that point has been shifted onto this link number 4. So that means what is the rotation of this angular velocity of link number third? So as we can observe here, the instant center is here on the right side and linear velocity is in the upward direction on the left side. So this velocity, this will be actually the radius, this between a I1 comma 3 will be the radius. So this velocity will be rotating this follower in this orientation. I can just mention it here like this. So this will be actually the direction of rotation, this will be the rotation of link number 3, which is actually, as we can observe, this is clockwise orientation. So that means angular velocity of omega 3 is negative. So we can input the negative sign here, for example, no issue. So in a similar manner, so we can also observe that what will be the direction of velocity of point B. So as we can observe that the instant center for this pin is also I1 comma 3. So as the follower is rotating in this clockwise orientation, so that means the velocity VB will be in this direction here, means towards right. So this will be the velocity of point B in the right side, because this will be rotating the this will not be violating the direction of rotation which has been calculated, the velocity of point A. So this will also be rotating because the instant center is below this pin. So the same angular velocity will be retained. So that means the velocity, this velocity of point B will be towards right in this direction. So when this point B will be shifted on to this link number 4, so I can write it here that the velocity of link number 4 will also be equal to velocity of point B, same in the magnitude and direction as it has been calculated here like this. So in this way this problem has been completely solved.